In this video, we're going to be looking at graphing other rational functions, in particular rational functions of the form y is equal to ax plus b divided by cx plus d. And these also have graphs that are hyperbolas. And here we see to find a vertical and horizontal asymptote is a little bit different. For the vertical, it's going to be the line x is equal to negative d over c. So in other words, it's the value of x such that cx plus d is equal to 0. And so if you solve that, you end up with the answer negative d over c. So in other words, you're just going to set the denominator equal to 0, and that x value, when you solve it, is going to be your vertical asymptote. And then the horizontal asymptote is the line y is equal to a over c. So those numbers in front of x, you're going to divide those, and that's going to be your horizontal. So let's go ahead and look at some examples of finding these graphs. So we're going to graph each function, and then we're going to state the domain and range. So my first step, as always, is going to be to figure out what my asymptotes are. Well, for my vertical, I know I need to set the denominator equal to 0 and solve for x. So I'm going to have x minus 3 is equal to 0. And when I solve that, add 3 to both sides, I get that x is equal to 3. So that's my vertical asymptote. So I'm going to go ahead and draw that in. So I'm going to go to 3 on my x-axis and draw in a dashed vertical line. And then for my y, we see up here that that is equal to a over c. And a is your number in front of x on the top, and c is the number in front of x on the bottom. So that means that my a here is 2. And my c, there isn't a number in front of x, but that means that there's really an invisible 1 there. So it's going to be equal to 1. So that means that my horizontal asymptote is that y is equal to 2. So I'm going to go to 2 on the y-axis and draw in a horizontal line. Okay, so now let's create a table of values to find some points that are on this line. So my vertical asymptote is at x equals 3, so I want 3 points to the left and to the right of that. So 3 points to the left of that, that can be 0, 1, and 2. And then 3 points to the right of 3, I can do 4, 5, and 6. So I'm going to first plug in 0, and so you can do all of this in your calculator, but I'm going to see what that looks like. You would do 2 times 0 plus 1 over 0 minus 3. And when you calculate that, you should get negative 0.33. Doing the same thing with 1, you have 2 times 1 plus 1 over 1 minus 3. And so that's going to get you negative 1.5. And following along with that, when you plug in 2, you should get negative 5. 4, you should get 9. 5, you should get 5.5. And then 6, you should get 4.33. And so graphing that, I have 0, negative 0.33, 1, I have negative 1.5, and then 2, I have negative 5. And so that's going to be my first branch, so I'm going to follow along my horizontal asymptote here. And then follow along the vertical, and I get that branch. 4, I'm at 9. And then 5, I'm at 5.5. And then 6, I'm at 4.33. So do the same thing here. And so that's the graph of this function. And then for domain and range, the same thing as before. My domain is going to be basically that x can't equal where my asymptote is at. And so that's going to be that x cannot equal 3. And then range is going to be that y cannot equal where my horizontal asymptote is at. That is at y equals 2. So that means that y cannot equal 2. Okay, let's look at one last one. And so here I have f of x is equal to negative 3x plus 2 over negative x minus 1. My first step is to figure out what my asymptotes are at. So to find my vertical, I need to set that denominator equal to 0 and solve for x. So I have negative x minus 1 is equal to 0. I can add 1 to the other side, and I get negative x is equal to 1. And then to get rid of that negative, I need to divide both sides by negative 1, and I get that x is equal to negative 1. And so graphing that, it's going to be vertical line through x equals negative 1. My horizontal asymptote is going to be y is equal to a over c. Well, my a value here is negative 3, and my c value is negative 1. So this is going to be negative 3 divided by negative 1, and so I get that y is equal to 3. So I'm going to go 3 on my y-axis and draw in a horizontal line. And now I need to figure out some points for my two branches. So I want 3 points on the left-hand side of my vertical asymptote and 3 points on the right. It doesn't matter which points you choose. I'm just going to go ahead and do the 3 immediate to the left and to the right. And so my vertical asymptote's at x equals negative 1. So 3 values to the left of that would be negative 4, negative 3, negative 2. And then 3 points to the right would be 0, 1, and 2. So plugging in negative 4, I have negative 3 times negative 4 plus 2 over negative 3, not negative 3, negative 4 minus 1. And when you put that in your calculator, you should get 4.67. And then following that same thing, when you plug in negative 3, you should get 5.5. Negative 2, you should get 8. 0, you should get negative 2. 1, you should get 0.5. And 2, you should get 1.33. So applying those points at negative 4, I'm at 4.67. Negative 3, I'm at 5.5. And negative 2, I'm at 8. And so my first branch looks like this. Remember to follow along those vertical and horizontal asymptotes. At 0, I'm at negative 2. 1, I'm at 0.5. And then 2, I'm at 1.33. And so following along, I get that branch. And then lastly, it asks for the domain and range. And remember, that's going to be where your horizontal and vertical asymptotes are, because the graph does not cross at those values. So that means that my domain is going to be that x cannot equal negative 1, and range is going to be that y cannot equal